Today's lesson is on angle-pair relationships, and I'm actually re-recording this because I made a couple of errors the first time. So I'm leaving the essential question here. So take just a second, write down the essential question, or you can do it at the end, and I'm just going to roll on. Essential question: how can I use facts about angle pairs to find angle measures? Let's start with our terminology. Two angles whose sides form two pairs of opposite rays are called vertical angles. It always helps to have a visual representation. So I'll put one like so here. So here's a pair of opposite angles. Here's a pair of opposite angles. And those two pair together give me sets of vertical angles. And something I think I need to note here, because it isn't further down in the notes, is that vertical angles are congruent. So keep that in mind. You'll need to use that when we go to solve one of our examples toward the end of the lesson. So these are vertical angles. And we've got next two adjacent angles whose non-common sides are opposite rays. So let's draw some opposite rays here. I'll do this right underneath. So there are opposite rays, and remember, adjacent angles just means that they share a side, so it doesn't matter where I draw this other side. But what I got there is adjacent angles whose non-common sides are opposite rays, and this is known as a linear pair. That's a linear pair. Linear pair will always be adjacent angles. All right, how about two angles whose measures have the sum of 90 degrees? Those would be complementary angles. Pretty sure you learned that many years ago. The sum of the measures of an angle and its, we don't need that apostrophe there, its complement is 90 degrees. And I think you've learned this in the past too. Two angles whose measures have the sum of 180 degrees are called supplementary. And so therefore the sum of the measures of an angle and its supplement is 180 degrees. One thing I do want you, I think you should take this space over here and draw yourself some pictures of complementary and supplementary angles. And I want you to think about this for a second. Oh, let's see. Would these two be complementary? Write down whether you think they are complementary or not, and let's talk about it tomorrow. And let's do the same with supplementary. Draw yourself some examples there. We'll talk about it in class tomorrow. I'm interested to see what you think. All right, here are our examples. So what do we know here? Well, we know that if this angle is a right angle, it measures 90 degrees, which would mean this angle here also measures 90 degrees. So that means these two angles in the picture are complementary, and we know their sum is 90 degrees. So let's just write that down. Solve for x. 7x plus 9x is 16x minus 6 equals 90. So 16x equals 96. So therefore x is going to be 6, right? And it doesn't tell us to find the measure of the angles, so we got our answer there. X equals 6. All right, what we have here is a linear pair. because we got opposite rays here, and then we got this common side, which means I've got adjacent angles, and since the two non-common sides are opposite rays, they're a linear pair. They're supplementary, so I know that 7x minus 16 plus 6x minus 12 equals what? 180. So 13x equals 180. I'm going to add the 16 and I'm going to add the 12. So 13x is going to be 208, and that tells me that x is going to be 16. I should put a box around my answers. And here's an interesting one. This actually uses a reflex angle. You remember I told you a little while back that angles that measure more than 180 are called reflex angles, and I told you we wouldn't do much with them, and we won't, but this just happens to be one. What I need to do here, I'm just going to use the angle addition postulate here, right, to find I know that the measure of this green angle, x minus 1 plus 24, equals whatever the measure of that green angle is. Well, how can I figure that out? Let me come over here and do that. I know that the degrees in a circle, if I went all the way around here, this would be 360 degrees. So if I want to find the measure of my green angle there, what I got to do is say 360 minus 295, and whatever that gives me is going to be the measure of this angle right here. So that's going to be 65 degrees, I think. So what I know then is that x minus 1 plus 24 is 65. So that's x plus 23. So that's going to give me 65 minus 23. So x is going to be 42 in this case. All right. Remember, if you have any questions or any confusion, put a star on this problem or write a note over here in the left somewhere or down at the bottom so that you can be sure to ask when you come to class. And finally, we have one more example here. What do we have? We have vertical angles, right? We have vertical angles here. So what did I tell you just a few minutes ago about vertical angles? They're congruent, right? Which means their measures are equal. So what do we have? We got 5x minus 12 equals, oh, it's very hard to read, but I think it's 3x plus 12. If it isn't, you can correct me tomorrow. We'll go over it again. So we're going to solve for x. 5x minus 3x is 2x, and 12 plus 12 is 24. So x is going to be 12. And if we just have to solve for x, that's all we need to do. If we want the measure of the angles, then I can plug it into either one. Let's see, 5 times 12 is 60. 60 minus 12 is 48. So it looks like each angle measures 48 degrees. I think we only had to solve for x. But anyway, all right, there you go, your lesson on angle pair relationships. Please make sure you have your essential question and make sure you write a good summary to tie up this lesson.